Hello and a very warm welcome to a new MikroWin 2020 tutorial. In this video, I will show you how to properly assemble and configure the metadata columns in MikroWin. Metadata is the digital label of your samples. It provides crucial context to your raw measurement values, such as sample IDs, dilution factors, or important remarks. Before we jump straight into the software, there are two important golden rules you should keep in mind. First, the settings for metadata columns are protocol independent. This means your configuration applies globally to the entire MikroWin installation and across all protocols used. Therefore, it is best to think of a structure beforehand that works universally for your daily laboratory routine. Second, pay close attention to choosing the correct data type. If you want to use a column for calculations, such as a dilution factor, it is mandatory to select a numerical data type. For sample IDs or patient names, it is best to choose the text data type. In MikroWin, we first activate the main category measure. To configure the metadata composition, it is necessary to clear the rack layout beforehand. We click the Clear Layout button at the bottom of the view. Right-clicking a metadata column header opens a context menu, which allows us to configure the corresponding column. The first two columns, position and layout type, cannot be customized as they are required to remain unchanged. The context menu offers three options for editing. Through the Insert Column menu item, we can add a new metadata column to the right of the currently selected column. The Remove Column menu item allows us to delete the currently selected metadata column from the configuration. Finally, the Customize Column menu item opens a dialog window where we can configure detailed settings for the respective column. For demonstration purposes, we now want to add two additional metadata columns. One column is intended to hold a dilution factor for the subsequent calculation of the original concentrations, while another is designated for the sample collection date. Both new columns are to be placed to the right of the already existing ones. By right-clicking the column header of the Remarks column, we open the context menu and add a new column, which immediately opens the dialog for configuring the properties of the new column. We choose Dilution Factor as the name for the new column, and the label identifier should be dilution. It is essential to note that the label identifier must not contain any spaces or special characters. We select Number as the value type and set the value culture to English. A dilution of 1 should be used as the default setting. To make it easier for the user to enter the dilution factors, we also create a lookup table with the values 1, 5, 10, 50, and 100. These values can then be conveniently selected via a context menu. We confirm our entries with a click on the OK button. By performing another right-click on the column header of the dilution factor column, we add the second column and again open the dialog to customize the column properties via the context menu. Here, we assign the name Sample Date and set the label identifier to Sample Date. This time, we select Date as the value type and again set the culture to English. A default value or a lookup table is not required in this case. Finally, we confirm our entries with a click on OK. We will now start a test run using our new metadata columns. To do this, we open the CurveFit protocol and enter metadata for 8 samples. In the sample ID column, we use the identifiers sample 1 to sample 8. We leave the remarks column blank. We set the dilution factors for sample 4 and sample 7 to 50, and for sample 3 and sample 6 to 10. We leave the remaining dilution factors at 1. We set the sampling date for samples 1 to 4 to today's date, and for samples 5 to 8 to yesterday's date. The preparations for our test run are now complete, and we can start the measurement by clicking the Start button. We enter test run 123 as the test run identifier and wait a few seconds for the virtual reader to generate the simulated measurement data. Toward the end of the measurement, we switch to the results view. The results view currently does not contain any information about the new metadata. To change this, we first need to adjust the curve fit protocol. We switch to the protocol view and select the calculations category. There, directly above the first calculation step, we insert a new step of type reading. We assign sample IDs as the identifier and select the sample ID label in the data selection section. Directly below that, we add another step, this time of type calculation. We assign sample dates as the identifier and enter the following formula. This converts the value contained in the metadata into a readable date format. Finally, we add a third step of type reading in the subsequent position, this time using the identifier dilution factor, and selecting the corresponding dilution label. We now switch back to the results view to check how the new data is displayed in the results list. In the next step, we apply the dilution factors to the concentrations from the curve fit calculation to display the original sample concentration. To do this, we switch back to the protocol view and add a new step of type calculation at the end of the list. We assign final concentrations as the identifier and enter the following formula. The variable curve fit represents the sample concentration as it was determined in the previous calculation step. By multiplying this value by the corresponding dilution factor, we obtain the original concentration of the tested sample. Finally, we switch back to the results view to check how the new data is displayed in the list. The attentive observer may have noticed that the standard and control positions are no longer displayed in the results view. As a general rule, if the result of the first calculation step for a position in the rack is an empty string, no output is generated for that position. Since we only transferred sample IDs for the sample positions in our example, the standard and control positions are no longer displayed. To correct this, we define an alternative calculation for the first calculation step with the identifier sample IDs for the controls used in the protocol. To do this, we switch back to the protocol view and select the types category. Here, we sequentially select the standard and B0 standard types and enter the following formula for each of the first 3 calculation steps in the type-specific adjustment of calculation formula section. Now we switch back to the results view and see that our output once again contains results for the standard and control positions. That's it for our tutorial on configuring metadata. Thank you for watching, and good luck with your work with MikroWin.